Good morning, good afternoon, or good evening, depending upon where you are in the world, and welcome to today's webinar, Avenger96 and DH Electronics STM32MP1-based SOM product family, brought to you by Tech Online, ST Microelectronics, Arrow, and broadcast by AspenCore. I'm Chris Keach, and I'll be your moderator today. We have just a few brief announcements before we begin. First, the slides will advance automatically throughout the event, and you may also download a copy of the slides by clicking on the green folder icon located at the bottom of your screen. You can participate in our Q&A session by asking questions at any time during this webinar. Just type your question into the Q&A text area located to the right of the presentation window and then click the Submit button. Please note that we'll try to get to as many questions as we can in the time that we have left at the end of today's program. However, if we're unable to get to your individual question today, someone will get back to you after the program is over. Also at this time, we recommend that you disable your computer's pop-up blockers, and at the end of the webinar, we will ask you to complete our feedback form. Your feedback will provide us with valuable information on how we can improve future events. You can also launch the survey at any time by clicking on the red survey button at the bottom of your console. And if you're experiencing any technical problems, please type your issue into the Q&A text area, and we will be glad to offer one-on-one assistance. And now, on to the presentation. Avenger96 and DH Electronics STM32MP1-based SOM product family. Discussing today's topic are Andreas Geisreiter, Product Manager, DH Electronics. Andreas is part of the hardware development team at DH Electronics. As Product Manager for the DHSOM products, he is your first contact person in the area of system on modules, and thanks to his many years of experience, he can advise you on the advantages, special features, and applications areas of DHSOM products. And joining him today is Marinus Holzner, Hardware Developer, DH Electronics. Marinus, Hardware Developer, is an engineer of the SOM design team at DH Electronics since 2018. Besides his passion for designing electronics, he is also an enthusiastic person about the whole field of Internet of Things and bringing his computing power to the edge of the network. It's with great pleasure I now turn this special session over to Marinus to begin. Marinus, take it away.
Hello everybody, and welcome to this webinar also from my side. So today we're talking about the Avenger96 and the STM32MP1-based system on modules designed by us, DH Electronics. My name is Marinus and I'm one of the hardware developers from the system on modules design team. And together with my colleague Andreas Geisreiter, who is the product manager of our whole system on modules product family, we will guide you through this webinar. At first, I'd like to give you a small overview about the agenda. The first topic is a small introduction about us, DH Electronic. Then we will go over to the STM32MP1 itself, and after that we will show you our system of modules based on the STM32MP1, and of course we're also talking about some software related to the MP1 as well as to our system of modules. And for the very end, we're also showing a video of a demo application which we've done together with a startup to show the capabilities of the STM32MP1 itself. So at first, let's start with DH Electronics. DH Electronics was founded about 25 years ago, and since then our team has grown to about 40 employees. And if you'd like to visit us, you can find us in the south of Germany, in between of Munich and Salzburg. And from here, we're serving the global market. And when talking about serving the global market, we are doing this with three main product areas. The first one is of course our system of modules. But beside of them, we're also having a product line for HMIs as well as for some IoT applications. But as you know, a standard product you can get off the shelf is not always a perfect solution for every situation, right? To solve this issue, we're also offering customized variants of our own products. So, for instance, if you're interested in, let's say, maybe one of our HMIs, and then once you've taken a closer look to it and you realize that it is fine except of maybe some missing features, like for instance an additional Ethernet port. In such a situation, we can modify the design just for your specific use case, and therefore you receive an individual variant which not only fits some of your requirements, but really fits all of your requirements. And in addition to these modifications, we are also providing our knowledge in terms of a complete electronics design as a service. The most interesting part about this is the fact that we're not only having the hardware, but also the software know-how in-house. And therefore, for you as a customer, you get your complete product designed by just one vendor, which makes it very convenient for you. Beside of our own products, we'll also help out with some trainings and workshops in which we can figure out together how we can improve the features of your products for your customers. And finally, we're also partnered up with Arrow so that you can get an easy support wherever you are. On this slide, we are showing our complete product portfolio. On the left, you can see the DH Core and the DHCOM, which are both part of our system on modules. You can see that the DH Core series on the very left are a little bit smaller compared to the DHCOM system on modules. But the main difference of these two product families is the fact that the DH Core is a solderable SOM, while the DHCOM is a pluggable SOM. But before we dive deeper into the SOMs, I'd like to take a minute to show you all the DHCON and DHMI features. The DHCON is the main component for our IoT applications, in which it is used to collect all the local information and publish it to the cloud. You can not only use it inside of a switching cabinet to interface to your existing electronics over a wired connection, but instead you can also populate it with wireless interfaces like Wi-Fi, Bluetooth, 4G or even NB-IoT, just to name some of them. On the right hand side, you can see our DHMI touch panel computers. These HMIs are available in different screen sizes and touch technologies, so you can get them with a resistive touch panel or if you want to also with a capacitive touch too. But the most important topic about these two product lines is that they're running on our very own DHCOMs, which make it very easy for you to configure them with as much power as you need it in your individual use case. So therefore you can maybe have a very low powered HMI panel which maybe only displays a website from an existing web server, or if you need it, you can also configure, like for instance, your DHCON device with a quad-core SoC, so that you can use it for some edge computing applications in which you might process all of your heavy data before you publish it up to the cloud. So it's really up to you what device you put in there. But just like already mentioned, a standard product does not always match the requirements. And that's why we're also able to provide you with the full spectrum needed for a custom design. So in the beginning, we can start with a workshop in which we define together what are the essentials for your customers and how we can turn these ideas into an actual product. And then, once we figure out a plan, we can start with the actual engineering. Here we are able to do the complete design in all three areas within DH electronics. This means that our engineers are designing all main components, which are the hardware, the software and the mechanics for the final product. And since we're handling the product management too, we can make sure that everything works together seamlessly. But as you know, the design process of the product is just half of the journey, because once the first prototypes are ready, we're also able to handle the approval testings, which are required to be compliant to the target market. And finally, we're also able to handle the production and the logistics too. So in the very end, you get your idea turned into an actual product which is ready to be brought to the market, and all of that without the difficulties of working together with many different vendors. Okay, so in the next step, let's talk about the STM32MP1 itself. ST Microelectronics is known for its STM32 microcontrollers, and it is very famous for it. One of the reasons is the fact that the STM32 series is equipped with some great peripherals, and the MP1 is no exception of this. Therefore, I'd like to highlight a few of its features with this block diagram. The first being its Cortex-M4 core, which is clocked at 209 MHz. With this core, you can run all your existing code you've designed for your STM32 microcontrollers without the need of a huge modification. From here, you can also make use of some of its peripherals, like for instance CAN-FD or the two 12-bit digital to analog converters, as well as some advanced 16-bit motor control timer units. But the MP1 is very special because beside the Cortex-M4, the ST has also included a dual-core Cortex-A7 applications processor, which can be used to run a real desktop operating system like Linux on it. And when it comes to such an operating system, there are multiple scenarios in which a display might be needed. And therefore, for these scenarios, ST has also included a Vivante GPU, which gives you the ability to make some vivid hardware accelerated 3D graphics animations on it. So in this slide, I want to highlight the heterogeneous design of the STM32MP1. And when we are talking about some heterogeneous designs in the context of an SoC, this means that we are having multiple cores made of different architectures combined onto a single chip. And just like shown before, the STM32MP1 is equipped with a dual-core Cortex-A7 together with a Cortex-M4 core. But what does this mean in a real-world application, right? Well, I'll show it to you. On the left, you can see all the high-speed and processing intense peripherals, which are interfaces like a 24-bit parallel display interface, 1 GB of DDR3 memory, we're having a gigabit Ethernet connection, or multiple USB ports. And of course, all of these interfaces are connected to the Cortex-A7 cores, which are also running the Linux operating system. But even though these cores are capable of handling these intense interfaces at once, they lack one big feature, which is the real-time capability. And this is where the Cortex-M4 core shines, because on this core you can handle all the real-time workload, like for instance some precise motor controlling, which relies on an exact timing, while the Cortex-A core is handling all the high-speed interfaces. And maybe you think right now, this could be done with two dedicated chips too, right? But the huge difference to this single chip design is the way these cores are connected to each other. Because the STM32MP1, you can make use of the features like the shared memory, which give you a very direct way to access the data by both cores at once. And therefore you don't need any additional communication between multiple chips. But we'll go a bit more into the detail about the performance of the intercore communication later on. But for now, I'd like to show you more about our SOMs. So for the next topic, we'll concentrate on the usage of the STM32MP1 in our System on Modules product portfolio. First, what are the advantages of using a System on Module? Well, there's a bunch of reasons, but I just want to highlight a few of them. The first one is you're getting a very short time to market, because during the development process, you can really concentrate on your key features. So let's imagine you're designing a measurement device. In that situation, you can concentrate on all the sensing and all the measurement part, while at the same time the complete computing part is done on the SOM. And this gives you more time to focus on the things that actually matter for your application. But then there's another aspect, which is speaking for the usage of a system on module, which is the increasing design success. And what do I mean with this? Well, the computing part can be quite complicated, and therefore there are many parts where an error might happen during the development process. In order to avoid this issue, you can just rely on an approved system by using a SOM. And finally, our DHCOM SOMs are sharing the family design, which means that they are interchangeable. So maybe once you've designed your hardware and it is running fine for a few years, you might reach a point on which you want to add some more software features, but then you realize that your SOM is not powerful enough anymore. In that case, you can just pick up a new DHCOM module and populate it on the same baseboard, and therefore you can increase the capabilities of your product without the need of a huge redesign. So, here you can see both of our system of modules. On the left, you can see the DHCOM, and on the right hand side, you can see the DHCore module. If you're seeing this slide, you might wonder, why are we offering the same SoC in two different form factors, right? But before I provide you with the answer to this question, I'd like to take the chance to tell you everything about our SOMs in detail. So let's start with the DHCore. You can see the DH core is a quite small PCB with a size of only 29 by 29 mm, which is slightly more than a square inch. On the bottom side of the SOM you can find an LGA grid. However, during the manufacturing, a LGA grid can be quite challenging because there is the risk of air bubbles inside of your solder balls, and which then lead into a bad connection which might break down over time. In order to avoid this issue, we've already put some solder onto our LGA grid, and therefore, as a result, you're seeing an easy and safe production. And actually, it turned out that this design is working so well that it is even easier when it comes to the prototyping of your boards. The main component of the DH core module is its SoC, which is available in basically three main variants. On the left hand side you can see that there is the series 151, the series 153 and the series 157, but I'll just call it series 1, 3 and 7 for now. The series 1 is the low-end version, which is having a single-core Cortex-M4 core and a single-core Cortex-A7 core. If you need more computing power, you can also choose the 3 series, which is having a dual-core Cortex-A7 instead. And if this is not enough power for you either, you can also upgrade to the 7 series, which is having an additional GPU. But since the MP1 is also going to target the IoT market, and therefore also the low-end variant might be connected to the internet, ST has decided to provide all of these variants with and without a dedicated cryptographics core, which can be used for hardware-accelerated encryption, decryption or generating hashes. And in the beginning of this year, ST has also made an upgrade to the STM32MP1, in which the Cortex-A7 cores are now running with 800 MHz instead of 650 MHz. And of course, we're also supporting these upgraded variants with 800 MHz too. So actually, this table is available with 650 MHz for the Cortex-A7 cores and with 800 MHz as well, which makes a total of 12 different variants of the SoC to choose from. And like said in the beginning, we're supporting all of these variants on this SOM. So on the lower left corner of our SOM, you can see the PMIC, which is the companion chip for the MP1. This PMIC generates all the voltage levels required to run the MP1 and all its necessary components. So for you, all you have to do is to provide this SOM with a 5V power supply, and from here all the additional voltage levels are generated by its own. But the ST PMIC-1 is a quite powerful PMIC, and therefore we're having multiple power rails which are routed back to the baseboard. So for instance, you can make use of the 2 USB power switches and use them for USB ports placed on your baseboard. Or if needed, you can also use the additional buck converter and all of the 3 LDOs to generate some voltage levels required in your specific use case. On the lower right corner, we're having a 2 MB sized quad SPI NOR flash. But you might wonder, why are we using such a small storage? Because this is of course not enough to store a real operating system like Linux on there, right? That's because we are using this small flash storage to just store the bootloader on it. And this in return results into an unbreakable design. Just imagine a situation in which your main storage is worn out or maybe broken down over time. In such a situation, you still have your bootloader running on your device, which gives you the ability to do some basic interaction with it, even though it won't boot up the main operating system anymore. But some of our customers feel more confident with an all-in-one design, and to have a solution for them too, we've also have an option in which we populate a 128 MB sized stacked NAND NOR combination on there, which is enough for a very lightweight Linux. However, in our point of view, we think that in most applications a bigger flash storage is needed. And with the DH core, you can choose the flash according to your individual needs. But as a result of this, you as a customer have to put this flash storage onto your baseboard, which is something many of our customers don't feel so confident about in the first place. But we think with the design in of an eMMC, which is very popular these days, it is not that complicated. So what are the issues someone is facing when designing in an eMMC? Well, the first one is of course the pretty tiny footprint of an eMMC, which requires a complex and expensive PCB stack-up. But the good thing is that there's actually a trick to it, how you can avoid this issue very easily. And actually, many of the pins of an eMMC are not connected at all, and therefore you can use these pins to route the signal over these pins instead of in between them. On the picture, you can see an actual eMMC design, and if you take a closer look into the center, you can see that many of the lines are routed over the pins instead of in between them. And this is possible because, like I said, many of the pins are not connected at all. But to make sure that you're also safe in the future, double check these pins you're overrouting not only with the datasheet of your eMMC, but also with the JEDEC standard. And therefore, you can really make sure that you're not using any pins which might be already reserved for future use by the JEDEC standardization. And with this simple trick, you can very easily simplify your PCB stack-up. However, there's also another issue with eMMCs, because unfortunately an eMMC can be discontinued every few years, and what leads us to the next issue, the lifecycle management. But thankfully for this topic the solution is even easier, and this is because we are also using eMMCs in our DHCOM system modules, and therefore we also have to do the qualification for new eMMCs. And then, once we've done this, we can of course recommend these parts to you too. And therefore, you don't have to worry about the lifecycle management at all, because you can just rely on the same eMMCs we are using on our other SOMs. And with these arguments, I think there is really no need to be afraid of the design-in of an eMMC memory. When it comes to the memory, we're supporting the maximum of the memory which can be addressed by the STM32MP1, which is 1 GB of DDR3L memory. But when you look at this picture, you might wonder, why did we choose to go for the 2-chip design, right? I mean, this board is already super crowded, and we just figured out that we didn't include any eMMC or any other bigger flash storage directly onto this board. So why did we then choose to go for the 2 DDR3 chips instead of just a single one? Obviously, there has to be some advantages, right? And the decision goes back to the fact that a single chip of 1 GB of size is a part which is produced by very few vendors out there. And when we have to rely on very few vendors, it can be problematic when it comes to the sourcing of the parts. So for instance, if one of these vendors decides to discontinue this single chip solution with 1 GB of size, it might be pretty hard for us to get an alternative chip to this from a different vendor. However, and DDR3L memory with only 512 MB of size is a standard component which is available by many vendors out there. And therefore, it is not only easier to source these parts, but also it ensures that we can provide all of our variants to at least 10 years to the market. And that's because even though when in a few years some vendor decide to discontinue this chip, it is still very likely that there are other vendors out there which are still producing this part, and thus we can make sure that we can provide all of our variants for at least 10 years to you as our customers. But for us as engineers, long-time availability is not such a fancy argument, right? I mean, we want to hear more performance-wise feature improvements. And actually it turns out that with a 2-chip design, we can get the maximum performance thanks to the 32-bit wide data bus from the DDR memory to the STM32MP1 itself, which is not possible with a single chip design. And therefore, with this design, you can really unleash the full potential of this SoC without any compromise. And in the real world, you can see these distinct performance improvements, especially when you're using a GPU. But you'll see some numbers about this later on. So if you're interested in the system module and you would like to start building your own prototype and proof of concept, you can do this very easily with the Avenger96. The Avenger96 is our reference design we've done last year together with Aero and STMicroelectronics to highlight all the capabilities of the STM32MP1. It is equipped with many peripherals like an eMMC flash, a gigabit Ethernet PHY, a CSI bridge for interfacing a camera, or maybe a Wi-Fi and Bluetooth connection. We're also having HDMI and a micro SD socket and many more. And who knows, maybe one of these interfaces might be interesting in your application too. And for that case, I'd like to invite you to visit our website, because here you can find the open source schematic for the Avenger96. and therefore you can always take a look at how we have done all the connections from the SOM to the peripherals. And if it fits, you can use the Avenger96 as a reference for your very own design. So these were all the features of our solder-able DH core module. And for the next part, I'd like to introduce you to our DHCOM module. The first components I'd like to highlight on the DHCOM module is of course its SODIMM connector and its high-speed connector. These two connectors are standardized throughout all of our DHCOM system modules, and therefore once you've designed a carrier board, your baseboard will not just fit this specific DHCOM module, but instead it is compatible to the whole DHCOM ecosystem. And this gives you a few advantages. Just imagine you're starting developing your prototype, and in the beginning you thought that maybe a single core variant might be powerful enough for your application. But then once you got all the software running, you realize that maybe the application is not as running as smooth as expected, and maybe it is a little bit laggy. In such a situation, all you have to do is remove the current DHCOM module and simply replace it with a more powerful variant of this DHCOM module. But beside of this, the family design is also very helpful when it comes to the long-term availability. Like maybe in 15 years from now, ST Microelectronics might decide to discontinue the MP1. But maybe your baseboard is still doing its job fine as it should, and therefore you try to avoid a huge redesign, right? In such a situation, you can really rely on the family design, because even though the SoC itself might be discontinued someday, it is still very likely that we are having a new revision of the new DHCOM module with maybe an STM32MP2 or MP3, who knows, or maybe even newer. And it is still very likely that we are still having a new revision of a DHCOM module which is still compatible to the family design, and therefore you can really extend the lifetime of your existing baseboard by simply changing the DHCOM module to a new revision. Just like on the DH core, also the DHCOM comes with up to 1 GB of DDR3L memory. And of course, we're also having the same advantages which goes hand in hand with a 2-chip design here. And regarding the SoC itself, we're also supporting all variants, just like we do on the solder-able DH core. And this also includes all the updated 800 MHz variants. So this is the bottom side of the board. Let's continue on the top side of it. On the DHCOM, you can see that we have 2 dedicated Ethernet ports, and each of these Ethernet ports is running with a speed of up to 100 megabits per second. And you might wonder, why do we use 2 Ethernet ports? I mean, what's the use case for such a design? Well, if you remember, in the beginning, I've showed you our complete product portfolio, in which you could see our IoT gateway called DHCOM. And since it is used as a gateway, it has to be connected to 2 networks at the same time. The first one being the local area network on which all the sensors and all the other devices are connected, and the second one is of course the internet. And since both networks are connected on 2 different ports on a physical level, you can really get a very secure IoT gateway application. But as an alternative to these 2 Ethernet ports, you can also order the DHCOM module with its RGMII interface exposed to the high-speed expansion connector. From here, all you have to do is connecting an Ethernet PHY to the expansion connector, and then you can make use of a real gigabit Ethernet interface instead. So it is really up to you if you decide to get this module with a dual Ethernet configuration, or if you prefer a gigabit Ethernet instead. And while talking about connectivity, I also want to show you the Wi-Fi and Bluetooth module. Regarding Wi-Fi, we are supporting networks in 2.4 GHz as well as 5 GHz, with support for many modern protocols used these days. On the Bluetooth side, we are supporting dual mode Bluetooth 5.0, which gives you an ability to interact with all kinds of Bluetooth devices, no matter what type they are. So for instance, if you'd like to stream music to your Bluetooth headphone, you can do this with the Bluetooth Classic capabilities. But on the other hand side, if you would like to create a Bluetooth mesh application where we have to talk to some battery powered sensors, you can rely on the Bluetooth low energy features. So it is really up to you how you want to use this module. You can also see that this module is equipped with a PCB antenna, but beside of it, it also has an UFL antenna connector. So if needed, you can improve the connectivity with an external antenna. But if you don't like to, you don't have to. So additional, this module is smart enough to detect from which source it is getting a better antenna gain, and it is switching between them automatically. So the advantage here for you as a customer is that you don't have to mess around with any configuration of this module to select the proper antenna. And finally, this module comes with a pre-certification, what means that you can refer to these certifications when it comes to the compliance testing of your finished device. Other than the DH core, the DHCOM is equipped with multiple different storage systems. And these consist of a microSD socket. We're having a 2 MB sized quad SPI NOR flash to get again an unbreakable design. And in addition to these, there's also an eMMC included directly on board. But if you don't like to have all these different storage systems, don't worry, because when it comes to the ordering of the DHCOM module, you can decide which size of an eMMC you want, or maybe if you don't want to have it at all. And the same goes with the microSD socket. And therefore, you can really configure a SOM which really fits your individual needs. An additional feature of this DHCOM module is its external real-time clock. The advantage of this external RTC compared to the internal one included inside of the MP1 is that this one is more precise and it has a temperature compensation, which leads to an accuracy of 3 ppm throughout a temperature range from -40 degrees Celsius to +85 degrees Celsius, or in Fahrenheit from -40 to +185 degrees. But I'd like to give you some actual numbers here. When you compare 3 ppm to 50 ppm, which might occur in an application with a lot of temperature change and without any temperature compensation, you can see that after 1 month, the external RTC we are using is wrong by just 8 seconds, while the other one is off by more than 2 minutes. But beside of being very accurate, an RTC also needs to run very power efficient, because otherwise it would simply drain the battery life. And the RTC we're using here has a very low timekeeping supply current of just 240 nanoamperes, which leads to a maximum battery life. For the final feature of the DHCOM module, I would like to show you the 16-bit wide address data bus, which can be used to interface things like maybe an FPGA very easily. Okay, so that's it for the modules, so let's compare them again. So then there's still the question why we are offering the same SoC in 2 different form factors, right? And now I want to give you the full answer to it. On the left hand side, you can see our DHCOM module, which features the family concept. And therefore, all of our DHCOM modules are sharing the same pinning, which makes them also interchangeable. But with such a family concept, you sometimes can't make use of all of the features available by the SoC. So for instance, if an SoC has maybe more CAN buses available than we are supporting on our family concept, we can't route them to the SODIMM connectors, because then we would not be compliant anymore to our family design. And this is the key difference compared to the solder-able DH core on the right hand side. Because on the DH core, we are having an individual footprint for every new module. And as a result of this, we can make every SoC pin available to the baseboard. And therefore, you can use all of the features available by the SoC without any compromise. So, on the left hand side, you get the family concept, while on the right hand side, you get the maximum feature set available by the SoC. Also, when it comes to the manufacturing, you have to note that the DHCOM needs to be populated by hand, while the DH core on the other side comes on a tape and reel, and therefore it can be placed onto the carrier board automatically by our standard pick and place machine. And as a result of this, we think that the DHCOM module fits perfectly for low to mid quantities application, while the DH core is the better choice for mid to high quantities production, where an automatic manufacturing is necessary. So, that's it from my side, and for the next part of this webinar, I'd like to hand over to Andreas. Thank you.
Hello everybody, my name is Andreas Geisreiter and I will now take over from Marinus for the last part of the webinar. First of all, I'd like to introduce myself. So I'm responsible for the system on modules at DH and I'm working for the company since more than 10 years now. We will now continue the presentation with our unique cooling solution for the pluggable DHCOM family. The most important thing is that this cooling option is also capable with the new DHCOM STM32MP1 module. The main motivation for this solution was to reduce the CPU temperature without a complex heatsink and to increase the lifetime of the chip. With our so-called 5-cent cooling solution, we are mounting the CPU on the bottom side of the module. This gives us the advantage to connect the CPU with a simple gap pad to the mainboard. On the mainboard, we have at this area a copper pad without solder resist. This pad is connected with standard wires to the internal ground plane of the standard 4-layer PCB. This means the CPU heat can be transferred from the CPU housing via the gap pad to the mainboard. On the mainboard, the heat is spread via the internal ground plane over the whole PCB. At the example on the left side, we mounted our standard Pico ITX carrier board with the DHCOM STM32MP1 module in a small metal housing. This means in a closed box. Then we did the first test without gap pad between CPU and mainboard and started a benchmark test on both cores and an additional GPU benchmark test. With that conditions, the CPU gets 192 degrees hot. This is completely without cooling. Then we add the gap pad between the CPU and the mainboard and reduced the CPU heat to 165 degrees. In a second step, we did the same test. But additionally, we connected the bottom side of the mainboard to a mounting plate inside the metal box via a second gap pad. As I told you before, we are using standard wires on the 4-layer mainboard to connect the internal ground plane. Standard wires means through-hole wires which are also available on the bottom side of the PCB. There we placed also a copper pad without solder resist in our PCB design. So we can directly connect the gap pad on the bottom side of the mainboard. With this second thermal connection, we can further reduce the CPU heat to 150 degrees. So in summary, it can be said you can reduce the heat of the MP1 in this example by 42 degrees only by adding 2 simple gap pads to your design. So this is a cost-saving solution which really extends the lifetime of the chip. So now let's come to the software part of our webinar. On this slide you find an overview about the reference designs where the board support packages are based on. For the DH Core STM32MP1 we have our Avenger96 board. For this, we offer 2 Linux versions, one based on OpenST Linux and a second mainline-based version. It is very important to know that we support the GPU with both available versions. As I told you, the Avenger96 is a DH Core STM32MP1 reference design. This means the BSP supports by default all interfaces of this board. If you're using additional features of the MP1, in your own design with the DH Core module, you will start with the Avenger96 BSP as a reference and adjust the BSP to your needs. Next to the DH Core, we have our DHCOM STM32MP1 module. For this module, the BSP is based on our premium developer board. In case of the DHCOM, as Marinus told you, we have a compatible family concept. This means the full feature set of the DHCOM family is supported with our Linux BSP. For the DHCOM STM32MP1 module, we again support a mainline-based Linux version, currently based on 5.4 long-term support kernel, and we also support the GPU with this BSP. On the next slide, I'd like to explain in a fast way the main features of our software support for the system-on modules. First, as I told you, we support for both STM32MP1-based modules a mainline-based Linux version. This helps us in the further development and above all in the later maintenance of the BSPs for all projects. Then for all BSPs, Yocto project is supported. The next point is Qt support with GPU support for both board support packages. Then ST supports also the STM32CubeMX for the MP1. So you can use the STM32 familiar tool for the MPU too. Next to Yocto based system, we as DH Electronics also supports a Debian based system. As bootloader, we are using the most popular bootloader for embedded devices, the U-boot. And as usual for Linux, we have all our sources available on GitHub. On the next slide, I will introduce the Etnaviv GPU driver. As you know, the high-end version, the STM32MP1-based comes with an integrated graphic processing unit. The GPU vendor in that case is Vivante, and the GPU itself is called GC Nano. The problem here is that Vivante only provides closed-source binary drivers for their GPUs. Therefore, OpenST Linux contains a binary block driver for the GPU. Some years ago, the open source project Etnaviv was started from the Linux community to get an open source Vivante GPU driver for the official mainline Linux. Note that the naming Etnaviv means Vivante spoken backwards. But now let's come to the reason why I'm telling you this information. The Etnaviv driver is used in our mainline-based Linux versions to get the GPU support. And beyond, we as DH Electronics have upstreamed the MP1 Etnaviv GPU support to mainline Linux. The reasons why we are spending such efforts to the Etnaviv project are listed on this slide. So let's start with the main reason. Etnaviv is compared to the original Vivante driver an open source driver. Therefore, it is easy to maintain the driver over the time. Next to this, it is easy to debug the driver and fix bugs if some are present. And you can also use standard Linux profiling tools to find performance issues. And last but not least, with libdrm, the Etnaviv has a stable user space API. So it is easy to update your operating system to a newer kernel version. Normally, I would assume that the original Vivante binary driver brings better performance as an open source driver. But this is wrong. We run GLMark2 test with both drivers and the result is the performance is 100% comparable. So you have no performance disadvantages if you use the open source Etnaviv driver. On the last Etnaviv slide, we like to show the GPU performance differences if you are using MP1 SOM with 16-bit DDR3 connection compared to our 32-bit connection. The result is that you get really 50% better GPU performance if you are using a SOM with 32-bit DDR3 memory connection. This means if you are developing, for example, an HMI, I would strongly recommend to use an MP1 SOM with 32-bit memory interface. So now let's talk a little bit about heterogeneous SOCs. Before we dive into this topic, I like to explain the traditional way. There we have a microprocessor, for example the Cortex-A7. On this device typically Linux is used as operating system and the device is connected to the internet and handles all the protocol stuff like Ethernet, Bluetooth and so on. On the other hand, we have a Cortex-M microcontroller. This device handles all the feed bus and real-time stuff. To bring all together, we need an interface to connect both cores together. For this, we use typically interfaces like I2C, SPI, or UART. The problem here is that the interface speed is low and the communication and error handling must be implemented by yourself. So in summary, the implementation, testing and maintenance can be very time consuming. Next to this, we have now our heterogeneous SOCs like the STM32MP1 on the market. These devices combine different types of processor architectures in one single chip, with the main advantage that the interaction is handled inside the chip and the SoC vendor typically implements standard mechanisms for processor interaction. On this slide, we will have a look at the standard mechanisms for processor interaction. A well-known open source framework for communication between different processor architectures and different operating systems is the OpenAMP framework. On the Linux side, this is managed by the RPMsg framework, which implements a virtual serial interface. At the microcontroller, we are using typically bare metal code or RTOS implementations, and for both are OpenAMP implementations available, which provides the counterpart to the RPMsg on the Linux side. So OpenAMP is used for data exchange and communication between the two different processor architectures. Next to this, we have on the Linux side the OpenAMP remote proc framework, which can be used for lifecycle management. This means remote proc can load the M4 firmware and can start or stop the M4 coprocessor. As I told you before, RPMsg is used to exchange data between the different processors. But you can use two different variants which are shown in more detail on this slide. The first one is a before mentioned serial interface, which can be used with normal open read and write system calls and is represented as a TTY device file in the Linux file system. On the M4 side, similar functions are provided by OpenAMP to communicate with the Cortex-A. The second RPMsg implementation is a shared memory interface, which is represented in Linux also as device file. On the M4 side, there is again a similar interface implemented by OpenAMP framework. As summary, we can say that the serial interface is used as control interface between the two different cores, and the shared memory interface is used to transfer data. So that's all from my side to heterogeneous SOCs. I like to say that on the last slide of this webinar you find some necessary links to this topic. Now let's talk about Debian distribution as an alternative to Yocto. The main difference is that with Yocto you are building your own distribution, and therefore you are self-responsible for the maintenance of the distribution. In case of Debian, you're using the Debian Linux distribution, and therefore Debian is doing the maintenance over the years. As I told you, we are providing both solutions, Debian and Yocto. We updated this year our Debian system to the current version Debian Basta. As build system, we are using a system called Elbe. A ready-to-use version is provided as a Docker container, so you don't need to set up the build system by yourself. With Debian, we see the following advantages compared to Yocto. So first of all, official maintained packages. Then fast response to security issues and bugs. Incredible amount of packages. Easy installation via apt-get in a running Debian system. Good system security and long-term support. But I have to say that we currently not support the GPU with our Debian-based system. Therefore, we recommend to use Yocto if you are developing an HMI device, and for headless systems we recommend Debian. If you are also interested to use Debian in combination with an HMI, please let us know. So it is possible to get the GPU working also with a Debian-based system, but we don't provide this with our standard BSP support. On the last software slide, I like to speak about our software support model. First of all, we are doing the BSP porting and maintenance in-house and with partners. This means DH is not only responsible for the module hardware, we are also responsible for the software of our modules. So you get the complete solution from one hand, and you have only one contact for hardware and software of the modules. Next to this, we can also do a customer-specific BSP porting to your own hardware for you. The main software support is handled via our wiki, and if you get in contact with us, you have typically a direct contact to the developers. If we are doing something customer-specific for you, for example a BSP porting to your hardware, we are working with support budgets and our ticket system. This allows us to provide a detailed and transparent overview about the provided services. At the last part of the webinar, we like to show you with an example how powerful the STM32MP1 is. The example in that case is a motor control demo. The motor control algorithm on the M4 was developed by our partner company Etnaviv. They are specialists with sensorless control of brushless DC motors, and they are providing a design-in motor control solution based on the STM32MP1 platform. Next to Etnaviv, we as DH Electronics can provide a large partner network from several ongoing projects. So if we cannot provide everything for your next project by ourselves, I'm pretty sure that we have a partner who can support the missing part of the project. But now let's come back to our demo application. As I told you, the motor control is running at the Cortex-M4. The very unique thing on the Etnaviv solution is that the firmware can control very low speeds of the brushless DC motor without the usage of sensors. Also, a teaching algorithm is available to adjust the firmware parameters to the specific DC motor. Next to the M4, for real-time motor control, we have the Cortex-A7. The A7 runs a standard embedded Linux on it. A web server on the Linux system provides the motor data to the outside world, and the Qt browser with GPU support shows the web server content on a local 7-inch display. The data exchange via M4 and A7 is handled in our demo via OpenM shared memory interface. So, in conclusion, with the MP1, we have two independent systems running on one chip, embedded Linux, and next to this, real-time bare metal code on the microcontroller. I think this says all. With the MP1, you can realize applications on one chip where you needed in the past two independent controllers. On the next slide, I'd like to show you a video of the demo. In the video, you see the web server content with the motor data, motor voltage, torque, omega, and so on. With a small picture-in-picture, you see the real hardware. I think the video shows very good how well Etnaviv handles load and speed changes of the DC motor. And next to this, the Linux system on the A7 provides, without any performance problems, the graphical web server content to the internet. Okay, now let's summarize the webinar. We as DH Electronics are very proud that we can build the future together with ST and their fantastic new STM32MP1 processor, which fits perfect to the embedded market. And now let's summarize why the digital heroes should be your preferred partner. So, first of all, individual support. Made in Germany, creativity and innovation capability, availability tests and certification, complete solution from one hand, and a value-based cooperation. Now I'd like to say thank you for your time, and we are now here to answer all open questions. Thank you very much.
All right, well, thank you, gentlemen, for a great presentation. As a reminder, please fill out the feedback form that will open up at the end of the show. Thank you in advance for filling out the feedback form. Your participation in this survey will allow us to better serve you. We're now going to move on to the question and answer portion of our event. As a reminder, if you'd like to participate in our Q&A session, simply type your question into the text box located to the right of the presentation window, or you can click on the Q&A icon on the bottom of your screen, type your question in, and then click the Submit button. Please note that we'll try to get to as many questions as we can in the time that we have left at the end of today's program, or I should say right now. If we're unable to get to your individual question today, then someone will get back to you after the program is over. So, gentlemen, we have quite a few questions to go through here. And so let's go ahead and get this first one out of the way. Does the DH core have all peripherals available on the pinout?
So this is me, Marinus. Hi, everyone. I'll take this question first. And yes, other than on the DHCOM, the DH core has all its peripherals put to the bottom side to the pinout, so you can access all the features of the STM32MP1 on the DH core itself. So yes, all the pins are routed to the pinout.
All right, thank you, Marinus. We'll move on to another question here for you. Is the STM32MP1 suitable for low power or battery powered, in other words, standalone systems?
Yeah, this is Andreas. I take this question. Yes, the STM32MP1 supports low power modes. Therefore, the device is suitable for battery powered standalone systems. And we are also using the ST PMIC on our modules, and this part is mandatory to support full-featured low-power modes. And therefore, yes, the DH core supports low-power modes. DHSOM supports low-power modes. So, yeah, Chris, I think we can move on with the next question.
All right, thank you, Andreas. Our next question here says, how do you debug the code on the MPU and the MCU on the Avenger96?
Yeah, I'll take this question. You can use, for the debugging, the JTAG interface to debug the MCU as well as the MPU itself. But for more software-related topics like this, you will hear more about this in the future, in the following webinar, which is hosted by Timesys, and they are focusing more on the software part. So you will hear a little bit more about these software features in the next webinar.
All right, thank you, Marinus. Another question has come in that says, is the RAM for M4 376 kilobyte or 448 kilobyte?
This is again Andreas. I take this question. The RAM, the SRAM is split in different sections, but altogether the M4 has a maximum size of 448 kilobytes of SRAM available. So, yeah, Chris, you can move on with the next question.
Thank you, Andreas. Another question here asks about the DDR. So, what is the DDR3 RAM in the A7?
We support on the on both modules the maximum, which is supported by the STM32MP1 itself, which is 1 gigabyte of DDR3 memory, and we are using a DDR3L memory. And if needed, you can get it in sizes from 265 megabytes to 1 gigabyte. And the special thing here is that we are accessing the DDR memory with a 32-bit wide interface, and therefore we can really max out the performance here, and you have no bottleneck here. Chris?
All right, thank you, Marinus. Another question here. Is there a hardware TPM module for secure credentials?
This is again Andreas. No, we have no TPM module directly on the module. You can mount it on your own mainboard. But you can also use secure boot mechanisms of the MP1 to secure your system boot. And I think you find more information about this on the ST wiki. Yeah. So, yeah, Chris.
All right. Thank you, Andreas. Another question here says, what's the typical design life of your boards?
I'll take this question. And so we're mostly targeting the industrial market, and therefore a lifetime cycle of up to 10 years is a standard in our products. And for the STM32-based systems, we are supporting it as long as ST is supporting this SoC. And currently this is, I think, 10 years, so it should be like to 2030, I think, right now. Okay.
All right,
Chris?
thank you, Marinas. Thank you, Marinas. Another question here says, what is the speed of the RPMsg?
Yeah, this is again Andreas. I think the question would better, yeah, this question is better for the following sessions with timesys. So I think these are the specialists, but it is faster than you're using than if you're using typical interfaces like I2C or SPI, for example, to connect an external MCU. So it is an SRAM, so it is really fast. And we did also some tests in-house in the past, and we reached speeds up to 20 megabytes per second. So this should be possible, but I think this question should again be asked in the next sessions with timesys. So they are the specialists there. Yeah.
All right, thank you, Andreas. Thank you, Andreas. Our next question here says, will the boards be available in an industrial temperature range of, say, negative 40 Celsius to 80 Celsius?
It's me, Marinas, again. And yes, we are, like I said, we are targeting the industrial market, and therefore, of course, all of our modules are supporting the temperature range from minus 40 degrees Celsius up to plus 80 degrees Celsius. So yes, we support the temperature range.
All right, thank you, Marinas. Another question here says, is the Avenger96 FCC certified?
This is again Andreas. I like to answer these questions regarding the whole family of our DHSOM STM32MP1 modules. So we have Wi-Fi and Bluetooth only directly on our DHCOM module. And there we are using a module from Redpine. Now it's Silicon Labs, but yeah. And this module is pre-certified, FCC pre-certified. So yes, the Wi-Fi part on our DHCOM, on the pluggable module, is FCC pre-certified. And to the Avenger96, there we are using a module from Murata, the 1MW module. This is also pre-certified for FCC, but the module is not directly on our SOM. So this means in that case, you have a pre-certification for the module from Murata, but if you're using this module in your own mainboard, you have to do the certification by yourself because it's not on the SOM in that case. Okay, so Chris, I think that's all to this question.
All right, thank you, Andreas. Another question here for you. Is the DHSOM also available without Wi-Fi or Bluetooth?
I'll take this question again. It's me, Marinas. Yes, the DHCOM module, so both of our modules can be configured just for your individual needs. So, for instance, if you say, well, you want the DHCOM module with an eMMC included, but you want to have like maybe a smaller one, you can get it with a 4 gigabyte eMMC, and the same goes for the Wi-Fi Bluetooth module. So if you want to have it, you can have it when you order the board. And if you don't need the Wi-Fi Bluetooth module, then of course you also can order the DHCOM module without the dedicated Bluetooth and Wi-Fi module on the SOM itself. Chris?
All right, thank you, Marinas. Another question here says, where can I find an ELBE package or example project?
Yeah, this is Andreas. ELBE can be, so we provide for development, we provide a virtual machine. It's based on a Debian system, and this machine can be found on our wiki page. And there we also have installed the LB tools to build a complete Debian root file system. And this is a reference. This can also be used from our customers directly for the development. And some information about LB can also be found on our wiki. So we have some interesting links to the official LB pages where you'll find all additional information about LB. But typically our customers are starting with our virtual machine where LB is pre-installed. Yeah, I think this is all for this question.
All right, thank you, Andreas. Another question here says, do you support Ubuntu on the MPU?
I take this question, and no, we don't support Ubuntu on our SOMs. So what we support is Debian-based distro, so we have Debian, and we also support mainline-based Yocto. So we are only supporting Debian and Yocto projects here.
All right, thank you, Marinus. The next question for you says, can LB build can the LB built system be run on Windows?
This is Andreas. I'm not sure in that case. So we only used it with Debian systems. I think it is not possible to run LB directly on a on a Windows system. But I'm not 100% sure. But we are using it always in combination with a Linux system like Debian. Okay.
All right, thank you, Andreas. Another question came in that says, what support do you have for LoRaWAN?
So I take the question again, and we support LoRa on different products. So for the DHSOMs, we don't support LoRa directly onto the SOM itself. But we have different products which are also having support for LoRa and other communications. But this is a different product area we are having. So if you're interested in having a product which is also having LoRa, we can also support this, but with other products. Like in the beginning, when we showed you the complete product portfolio, you could see our so-called DHCOM device. And in here, we have support for the LoRa protocols. Chris?
All right. Thank you, sir. We've got another question here that says, can the M4 access the DDR3 directly?
This is Andreas. I don't think so, but I'm not 100% sure in that case. Maybe this would also be a question for the next sessions with TimeSys. I don't think that it is possible. I only know that the SRAM access is possible. I think DDR3 is not possible.
All right. Thank you, Andreas. We're going to move on to another question here that says, can I get the modules with pre-programmed software?
Yes, me, Marinus again. We can program some software onto the NOR flash. So we have like the 2 MB size NOR flash for the bootloader. So if you want to, we can program a custom bootloader on here. And we, of course, also can pre-program the eMMC flash too. So yes, if you need some custom programmed modules, we can handle these too.
All right. Thank you, Marinus. Another question came in that says, has bare metal or RTOS support on the A7 been tried yet?
We don't have tried this till today. It is possible, but we don't have tried this in the company. Maybe this would also be a good idea to have a look at the ST wiki. Maybe there are some interesting hints on the web page. Yeah, it is possible, but we as DH don't have tried it. Okay.
All right, thank you, Andreas. Another question here says, why do you provide a Debian-based system next to Yocto with your modules?
So it's me, Marinus. So the difference between Debian and Yocto is that Debian is an actual distro, and this means all the security patches and all the updates are handled by the Debian project itself. So you don't have to worry about all the security patches. While on the other hand side, with a Yocto, you have to, or you can build your own distribution, and therefore you can make a very specific image for your software. But on the other hand side, you have also to care about all the security topics and all the patches you need. But also this is something where Timesys might tell you a little bit more about in the next session, because they're having a tool how you can also handle the security features and the security updates in the Yocto project quite well.
All right, thank you, Marinus. We'll move on to another question here for you. Will future DH core modules with more powerful processors be pin compatible with current modules?
This is Andreas. So each DH core module is based on a different SoC platform and has, therefore, we have always an individual pinout. So it is not, and therefore you can make use, if you like to, the idea is to have access to all the SoC features, and so we always have a different pinout with our DH core modules. So with the DH core, it's we will not have compatible modules in the future, which supports more powerful processors. But in case of the STM32MP1, we plan to also support the 800 megahertz version, and this will be pin compatible to the current DH core modules.
All right, thank you, Andreas. Another question that's come in says, do you provide open source schematics for DHSOM modules and carrier boards?
I take this question. It's me, Marinus, and so yes and no. We do support open source schematics for our reference design board, the Avenger96. But of course, for the SOM itself, we can't support here the open source because this is our property and our design, so we can't share it here. But for the reference design, you of course do get the open source schematic.
All right, thank you, Marinus. Another question here for you is what does long-term availability mean in context with the STM32MP1? So
our modules are available as long as STM32MP1 is available. So today this means our module will be available till 2029, and yes, as long as MP1 will be available, we will also our module will also be available. Yeah.
All right, thank you, Andreas. Another question came in that says, how long does it typically take to compile an OS using Yocto?
Yeah, this depends on the computer you are using. So I tried it with my laptop, and it is a dual-core i5, and it takes really 22 hours to compile a complete Yocto system. So yeah, if you, I think you must use a powerful computer, and then it takes really, I think, 3 to 4 hours to run a complete Yocto build. And if you are doing changes afterwards, then it is much faster. So it takes only some minutes to build. But the first build with a very fast computer, it takes really 3 or 4 hours typically. Yeah.
All right. Thank you, Andreas. Another question here came in that says, what is the minimum order quantity for the DHSOM modules?
It's me, Marinus, again. The minimum quantity when it comes to the ordering for the DHCOM, so the pluggable system module, is starting at 1 pieces, And for the DH core, since they are coming on the tape and reel package, the minimum quantity is starting at 360 pieces per tape and reel package. So 1 piece for DHCOM and 360 for the DH core. Chris?
All right, thank you, Marinas. Another question here that says, can you suggest an eMMC that you route BGA pins in the tricky way from?
Yeah, this is Andreas. The housing and the pinout of the eMMC is standardized by the JEDEC, and therefore it works with every standardized eMMC part. So you don't have to use a specific part, eMMC part from a specific vendor. So yeah, if it belongs to the JEDEC norm, and you can use any eMMC combination with our SOMs.
All right, thank you, Andreas. Another question here that came in that says, what Linux kernel version do you recommend to get hardware accelerated OpenGL?
Yeah, so at the moment we support 4.19 long-term support kernel with OpenST Linux and 4.5 long-term support kernel version with our mainline-based Linux. For both versions, OpenGL is supported. Yeah, and typically we are always using long-term support kernel versions, and yeah, so with our current versions 5.4 and 4.19, OpenGL is supported.
All right, thank you, Andreas.
Okay.
Another question here. Will future SOMs with more powerful processors fit to the actual architecture so that in case for an upgrade, you just have to change the SOM?
I take the question again. It's me, Marinas, and for the DHCOM module, so the pluggable system, we are having the family design. So yes, when it comes to the pluggable systems, you can of course upgrade and your baseboard or your complete product by simply changing the SOM, because all of our future SOMs in the DHCOM form factor will of course be compatible to this form factor. But like mentioned, with a family design, you sometimes have to make a compromise when it comes to all the features which are available by the SoC. And so on the DH core, so the smaller one, the solderable SOM, here we've decided to make an individual footprint for all of our SOMs. So only the pluggable SOMs will be upgradable by simply swap them to a more powerful one, and the solderable are different. Okay, that's it, Chris.
All right, thank you, Marinas. Another question came in that says, according to the ST data sheet, the STM32MP1 has a 1 gigabyte Ethernet interface, but on the DHCOM you provide 2 times 100 megabit. Is a gigabit connectivity possible on a single interface?
Yes, you can make use of the gigabit port by choosing a different variant of our DHCOM module, but in that case you have to place a dedicated Ethernet PHY on your baseboard. Then gigabit Ethernet is possible. Otherwise you have 2 100 megabit ports available, and there we have the PHY also on our SOM. Okay, yeah. Chris, you can repeat with the next question.
All right, thank you, Andreas. Another question here for you. Can you give an example of what these modules cost?
I'll take this question. First, you of course can always contact your local sales guy from Aero, but just look it up to give you a reference, so some roughly numbers. Just give me 1 second. We're currently looking it up. So 1 second, please.
Sure, no problem. And if you'd like to ask a question again, just type your question into the Q&A text area or click on the Q&A icon. We'll get to as many as we can.
Yeah, just real quick because I'm just looking at lab live. It depends on the configuration. So to give you some numbers, now we have it. It's about 40, so 27 to 40 US dollars, depending on the module. Like you can get it with a single core and without the GPU, and also with the high-end modules like the dual core and the GPU. And this is all the prices for the DH core, so for the smaller solder-able SOM. But for more details, you can always, of course, contact your local Aero guy. Okay, that's it from me. So, Chris,
right. Yeah. Thank you, Marinus. Another question here came in that asks, do you have a representative and or distribution in the United States?
Yes, Aero. So, yeah.
All right, so contact your local Aero rep is what the gentlemen are telling you. For more information, they'll be happy to help you out. We're going to move on to another question here for you. Why don't you use the STM32 RTC instead of the externally mounted RTC?
I'll take this question again. And like we've shown in the presentation, the external RTC is way more precise compared to the internal one, while at the same time it is requiring a lower battery consumption. So this is like when you really have to rely on a precise RTC, the external one is the one which is giving the better results. And there's also the feature that it is temperature compensated. So if you have like an environment where the temperature is changing a lot, then we really recommend to go with the external RTC, which is on the DHCOM available. And if this is not so interesting for you, then you of course don't have to buy it and always can choose to buy your DHCOM module without the external mounted RTC.
All right. Well, thank you, Marinus. That does look like all the time that we have for questions for today. Once again, if we didn't get to your question today, someone's going to get back to you after the program is over. I'd like to thank Marinus and Andreas for a great presentation and Q&A session. For more information related to today's webinar, please visit any of the resource links available in the green folder icon at the bottom of your screen. And within the next 24 hours, you will receive a personalized follow-up email with details and a link to today's presentation on demand. And once again, if we did not get to your question, someone will get back to you after the program is over. We'd like to thank you for attending today's webinar, Avenger96 and DH Electronics STM32MP1-based SOM product family. Brought to you by Tech Online and ST Microelectronics and Aero. And this webinar is copyright 2020 by AspenCore. The presentation materials are owned by or copyright by Tech Online, ST Microelectronics, and Aero, and the individual speakers are solely responsible for their content and opinions. On behalf of our guests, ST Microelectronics and Aero, I'm Chris Keach. Once again, we'd like to thank you for joining us, and we hope you have a great day.